Hello everyone, I welcome you all to today's session, which is a continuation session from the previous videos. So today we have time and distance, concept video 4. So in this particular video, we shall be looking at few more concepts from time and distance, right? And this most likely is going to be the last video, right, in the series, right? If there is any specific topic that you want me to cover from time and distance, please do write it in the comments, alright? And please do subscribe to our channel so that you get notification whenever we release new videos, right? And we don't only make concept videos, right, like this. We also make videos on question discussion, right, which I believe would be really helpful for any aspirant who is planning to take CAT this year or the next year, right? So please ensure that you subscribe to this channel. Right. Let's get started. So the very first thing, the areas that I will be covering here are problems involving trains and races, right? Particularly, I will be taking the linear races, right? Do tell me if you want other kinds of races to be involved in these discussions in the comments. I will do it later then. If there is a need, we will do it, right? If there is a requirement, we will do it again, one more video later. But for today, we will look at problems on trains. So when we look at problems on train, we need to understand one very important aspect about the train, which is, if you take a moving train, let's say something like this, it has a length of, let's say L. The speed of the train is A meters per second, this is L meters, let's say. Now this train is moving towards right, it's going right. And while moving, let's say it comes across a person. Let's say the person is P. Now the question that I have for you to think about is, when do we say that the train has crossed this person? When and how will the train cross this person? Please visualize it. It would happen like this. The train is moving right. Now when the front end of the train will start crossing the person, we will say the train has started crossing the person. It's only when the rear end of the train crosses the person do we say that the train has actually crossed the person. Please understand. When the front end starts crossing, we will say, okay, the train has started crossing. It's only when the rear end crosses the person do we say that the train has actually crossed. So that means, in this process, can I say the distance travelled by the train for crossing a person will be nothing but its own length. I hope we see that here. The train is moving from this point to this point, right? This point to this point. It's travelling its own length. I hope you see that there. So thus can I say time taken to cross will be nothing but distance travelled upon the speed of the train. So many seconds, right? Now there could be one more case wherein a train is crossing another object of substantial length, say something like bridge or platform or another stationary train. So this train again is length L1, let's say. This object is L2 length, L2 meters, which cannot be ignored. This train is moving at A meters per second. So here, for this train to cross this stationary object, substantial length object, can I say the total distance it will travel will be nothing but sum of the lengths. I hope we can visualize this. So the train will start crossing like this. The train will start crossing like this, the front end of the train. The train will keep moving. Only when the rear end of the train crosses do we say that the train has crossed that stationary object. So that means, what is the distance that the train is travelling from front end to front end? This is the total distance. And what is it equal to? This is L2 plus L1. So L1 plus L2. So thus what will be time taken? Simple, distance by speed. So many seconds, right? Now there could be one more case wherein that object is not stationary but it's a moving train, L2. So in that case, we can have two cases. L2 is moving away at B meters per second. L1 is changing at A meters per second. This is L1. This is L2. Now in this case, for L1 to cross L2, what will be the time taken? If both the bodies are in motion, then we tend to use the concept of relative speeds. So here the time will be the total distance to be travelled, which is still L1 plus L2, divided by not just any speed but relative speed. So what will be relative speed of A with respect to B? They are moving in same direction. A minus B. So many seconds. Similarly, if they are moving in opposite direction, this minus will become plus. That's the only difference that we have. If the train B is moving like this, instead of going away, it's crossing L1 itself, it's moving towards L1 itself, then the denominator will become A plus B. So there are some basic details that we have pertaining to the trains that we should be aware of. Let's take up some examples from trains to understand the concept further. Have a look at this question. Pause the video, try out this question once yourself. So let's solve it here in the class. It says a train traveling at 90 kilometers per hour crosses a person traveling at 18 kilometers per hour in the opposite direction in 20 seconds. If the train crosses a platform in 50 seconds, find the length of the platform. Look at this. So train travels at 90 kilometers per hour. We don't know what the length is, let's say it is L1. It's crossing a person traveling at 18 km/h in the opposite direction. The train is going like this. The person is going opposite. That means the two people are moving in opposite directions. Now, if they are moving in opposite directions, can I say when we apply relative speed, so we keep the slower body at rest and we assume that only the train is moving with relative speed, which happens to be sum of the speeds. And please also notice everywhere here the time units are given to be in seconds. So accordingly, we'll have to convert this kilometers per hour into meters per second. So the method for doing that will be kilometers per hour speed into 5 by 18. When you do it, you will get 30 meters per second. So here the speed of the train, I will not take it as 108, I will take it as 30 meters per second. So here what is the distance to be travelled by the train to cross a person? Its own length. And how do we get the distance? It's nothing but speed into time, 30 meters per second into 20 seconds, which will give us 600 meters. So length of the train is known now, it's 600 meters, L1. Now later on, the train is trying to cross a platform. So this L1, which is 600 meters, it's trying to cross a platform now. Let's say the platform length is L. So the distance to be travelled by the train will be sum of the lengths of the two, right? Length of the train plus length of the platform. So this will be equal to what? Speed of the train, which will not be 30 anymore. Please note, it's going to be 90 km/h. So 90 km/h into 5 by 18, converting into meters per second will give you 25 meters per second. So the speed of the train is going to be 25, not 30 like the previous case, because here the platform is stationary. So this will be equal to what? Speed into time, which is 50, right? Time is 50. So that means 600 plus L is going to be 1250. So hence the length of the platform can be calculated as 650 meters. Right? It's going to be meters because we are taking length of the train also in meters here. Okay. So this is also in meters. Meters per second into seconds. This is also meters. We'll get our answer in meters only. So what is the length of the platform? It's 600 meters. That's the final answer. I hope we are clear with this. Now have a look at this. This is a problem on races now, right? So now we'll be solving a few questions on races. But before we discuss this question, I would just like to give you a brief about, right? Brief intro about the topic of races also, linear races. So if you have a certain race track of length PQ, P is the starting point, Q is the end point. So on this race track, let's say there are two people who are running the race. One is A, other is B. So there will be two kinds of statements given with respect to starting point, two kinds of statements given with respect to end point. So what are the statements? Let's look at it. He might say A gives B a head start of say 5 meters. So A gives B a head start or simply start, head start or simply start of 5 meters. What does that mean? So that means when the race begins, A will be starting at the, A will be standing at the starting point only, he will not be moving at all. Only when B has covered 5 meters, so B has started running. So only when B has covered 5 meters will A start running. So this way A is giving B an advantage. So that advantage is called as head start in terms of number of meters. But the same head start can also be given in terms of time. So it might say A gives B a head start or simply start of 2 seconds. So what would this mean? Again, A is standing at the starting point only, he is not moving. Only when B has ran for 2 seconds. So if I assume speed of B to be B meters per second. So only when B has ran 2B meters will A start running. So this is also kind of an advantage that A gives to B. This is also called as head start. So head start could be given to us in terms of distance or in terms of time. Similarly, now there are two kinds of statements that we have pertaining to the endpoint also. So what are the statements? Let's look at them. So here sometimes in the problems he would say A defeats or A beats B by 10 meters. So what would this mean? So this would mean A is the winner because A is beating B, A is the winner, and when A has reached the finish point, B was lagging behind by 10 meters. So this is the distance beaten. So A beats B by 10 meters means when A was at the finish line, where was B? B was 10 meters behind. Right? So same beating distance can also be given as A beats B by 3 seconds. So this would mean when A reaches the finish line, B will be somewhere behind here and B will take 3 more seconds to cover this remaining part of the track. So this distance will be covered by B in 3 more seconds. So if I assume the speed of B to be B meters per second, so can I say this distance is nothing but 3B meters. 3 into B meters, so if B is the speed of the person B, alright. So these are the two kinds of statements that we have pertaining to endpoints, two kinds of statements pertaining to the starting points. Now if I just try to, you can copy this if you want, if I just try to discuss this little more, notice sometimes he'll be giving you information about A beats B by X meters in a race of track length L. B beats C by Y meters in the same race. So then it will be asked A beats C by how many meters? Okay, the length of the track is L. So one thing should be clear to all of us, the answer is simply not X plus Y. Let me take a numerical value for that. If I say A beats B by 10 meters, so that means what? When A was at the finish line, B was 10 meters behind, right? B beats C by 10 meters. So that means when B is at the finish line, C is again 10 meters behind. So in this case, in this first instance, where will C be? Will C be 10 meters behind B? So for example, if it's a 100-meter race, A is at 100-meter mark, B will be at 90-meter mark. Here, B will be at 100-meter mark, C will be at 90-meter mark. Where will we see here? Will he be at 80-meter mark? Think about it. I hope you understand, it won't be true, because if C is at 80-meter mark, that means the gap between them is 10 meters. Here also the gap is 10 meters, which is clearly impossible. When B is moving forward, the gap will stretch a little bit. So here the gap is 10, that means here it won't be 10. So thus simply saying my answer is X plus Y will be wrong. In fact, there is a formula that you may recall, you can note. X plus Y minus X into Y upon L, where L is the length of the track. So this will directly give you the distance by which A beats C. Similarly, if I say A beats B by T1 seconds, B beats C by t2 seconds, then A beats C by simply its sum t1 plus t2 seconds. So in case of time you can simply add, but in case of distance you cannot simply add. There is one more factor that will come in, x into y by L. Alright, you can please make a note of it. Now we will start with the question that we have. So if you look at this question, if in a race A beats B by 20 meters and C by 39 meters, in the same race B beats C by 24 meters, find the length of the track. Now if you can recall the formula already, we can simply use the formula and say if A beats B by x and B beats C by y, which is 24, then A will beat C by x plus y minus x into y by L, where L is the length of the track, and this is given to be as 39. So when you solve this, you will directly get the value of L. 44 minus 39 is 5. So this will go 4 times. So we'll get the value of L as 96 meters. So if you know the formula, this is how quickly you can answer this question. Versus, what if you do not know the formula? Then of course we have the basic approach of time, speed and distance, which can be done like this. Observe, length of the track is L. A beats B by 20 meters means when A is at finish line, B is 20 meters behind. That means the time in which A covers L meters, B covers L minus 20 meters. Not just that, also note, he beats C by 39 meters, so C will be further behind. Right? So C covers L minus 39 meters. So based on this, can I say, since B and C are traveling this distance and this distance in the same amount of time, they are starting the race together. Nothing is given about the starting point. We'll assume they are starting together. The time in which A reaches here, B reaches to point B, C reaches to point C. So thus can I say the ratio of the distances, since time is constant, ratio of the distances will be nothing but ratio of the speeds. Correct? Next he also says B beats C by 24. That means when B travels L, C will travel L minus 24. Here what is the ratio of the speeds? L by L minus 24. Cross multiply this equation. Let's simplify. So when you simplify, by cross multiplication you will get L square. I am writing it directly, minus 44L plus 480 will be equal to cross multiply L square minus 39L. So when you solve this, again you will get the value of L as 96 meters. So if you don't know the formula, if you know the formula, of course it's pretty direct. It's just couple of steps, you will get your answer. If you don't know the formula also, then too we can answer it by using the basic concepts of ratio, right? The basic concepts of time, speed and distance. We'll still get the answer as 96 meters only, right? There could be more evolved, more difficult problems out here, right? But in this particular video, I have taken only one. I'll come back in the question discussions class, all right, with more higher difficulty questions from this linear races. But for today's class, this is what I have for you. So I'll be ending the video with that, right, with this question. Right? I hope you have followed it, right. Please practice more questions from time, speed and distance. And as I said at the beginning of the session, if you have any suggestion with respect to any particular topic you want me to take up, circular tracks for example, or escalators for example, or clocks for example, please do write in the comment. We'll definitely consider looking at the comments. If you want us to include a few more videos, we'll try to put in more videos. On that note, let me end the session here. Thank you and all the very best.